All right, here we have another problem where we're dealing with our complex zeros. This is use the given zero to find the remaining zeros of each function. So we have this g of x function, and they've told us that we have a zero here at negative 5i. Well, if we know that we have a zero at negative 5i, then that means we automatically have to have one at the conjugate because this is an imaginary number. So we have to have one at positive 5i also. We're still looking for that third. Now, how did I know that there were 3 zeros in this function? That's because this is a degree 3 polynomial. And degree 3 polynomials must have 3 zeros. Some will be real, some will be imaginary. Now, because we have 2 already, and we're looking for one more, that tells me that this must be a real number. Because if it were another imaginary, it'd have to be a pair, and we don't have enough room for that. So just by kind of using some logic, we can figure out that this one is a real zero. If we're looking for a real zero, we have a couple of options. We can either do it by hand, which is what I'm going to do to give us the practice at that. But you could also graph this original function on your calculator because you're looking for a real zero, which is an x-intercept, something you can see. You can see where it's crossing. So we could do that. But unfortunately, I'm going to do things the old-fashioned way, and we're going to do it out by hand. Now, if I have a 0 at negative 5, that means I have a factor of x minus negative 5, which would be the same thing as saying x plus 5. If we have a 0 at 5i, that means we have the factor at x minus 5i, which would look like this. So if I were to multiply this together, we would get x squared minus 5ix plus 5ix would cancel each other out, minus 25i squared. And I squared is technically a negative 1. So this is truly x squared plus 25. If I were to find this other zero, it would come from a factor. Well, if I don't know what this other factor is, I can use division to find it. We have this polynomial of x cubed plus 3x squared plus 25x plus 75. That's in perfect descending order. And we can divide that by our existing factor, x squared. Now we don't have an x, so I'm going to put in a 0 placeholder, plus 25. And now I can do the division. So x squared times x would give me x cubed. Finish multiplying it out. That would be plus 0x squared plus 25x. And now instead of subtracting, we're going to change our signs and combine like terms. So 3x squared, though those are gone, plus 0x's plus 75. Now x squared times 3 would give us, oops, sorry, didn't mean to do that. 3 would give us 3x squared plus 0x's plus 75. And then changing our signs, those would cancel, those cancel, and those cancel. That's extremely important because remember, in order for things to be factors, they have to divide in evenly. So that tells me that if I multiply this times x plus 3, we get this polynomial. So the other factor has to be x plus 3. That is beautiful because now from that factor I can find my last remaining zero, which would be negative 3. So the remaining zeros here are 5i and negative 3.